AP Chem Topic 3.9, Separation of Solutions and Mixtures. This is a repost of a video I made talking about a specific chromatography problem on the AP exam, and it covers this topic very well. So let's do some vocabulary first about chromatography. There's two phases. There's your mobile phase, which moves through the stationary phase. The stationary phase is usually solid, like in this example here is chromatography paper. And the mobile phase is a liquid most of the time in AP, or you can have a gas mobile phase as well. You do a calculation with chromatography called the RF, which is retention factor, the distance traveled by the unknown or component over the distance traveled by the solvent. So the solvent is going to be in some chamber here. You're going to stick your paper in it, and your paper is going to have spots of your unknown, in this case dyes, okay? So here we've actually got 3 known dyes and then an unknown, and then solvents in the bottom, and then it wicks up the paper. At some point, you'll take the paper out. You want to make sure you take it out before it runs off the top, and then you're going to mark the solvent front here, in that case there. For this question, it's really important to notice that the solvent fronts ended at different positions, okay, because that's going to impact your RF. So it might, when you're comparing the unknown to this, you can't just necessarily go straight across. You have to think of the RF value itself, okay, in identifying your unknown. So substances can be ID'd by comparing the RF of the known to the RF of the unknown, which is what I was just talking about. Make sure you pay attention to the difference in the solvent front ending position as we showed up there. And then substances move based on size to some extent, but more often in AP, we see them talk about it based on polarity. Size is actually a thing you can do with chromatography. It's just not one that we see discussed very often in AP. So substances that are more strongly attracted to the stationary phase don't travel as far. So they have a low RF. So if your stationary phase is polar, like chromatography paper is, then they're going to be more attracted to the paper, and it's going to not move as far. Substances that are more strongly attracted to the mobile phase travel farther. They have a high RF. So if they're less attracted to the polar paper, then they're going to keep moving more along with the solvent front. And so we would expect in this situation that dye B is more polar and dye C is more non-polar. Relatively speaking. And so if you're asked to justify those differences, then that can help you do that. So there you go. There's an overview of chromatography. By the way, there's a variety of types of chromatography, but they all basically work off the same general idea, although you can change details with the states of matter and also with the type of chromatography and the setup that you have. Hope that helps.